Alright, in this lesson, we're going to look at scientific notation. Our objective, understand what scientific notation looks like, understand how to switch from standard to scientific form and vice versa, understand how to add and subtract and multiply with scientific notation. Vocabulary is scientific notation. Compact method of writing numbers in the form a times 10 to the power of b. So this is the basic form of scientific notation. In this form, a is any number from 1 to 10. So it's got to be a number from 1 to 10, but it has to be less than 10. So if we use some of our previous knowledge, what this is 1 is less than or equal to a, which is less than 10. We don't want any numbers that are beyond the ones digit. So we don't want anything in the tens or hundreds digit. B is basically the power of 10. It's how many decimal places we have to move our decimal, basically, because if you multiply by 100, it moves it twice. If you multiply by 1,000, it moves it 3 times. So this tells us basically how many zeros are on this 10. So if b is 1, it's just a 10. If b is 2, it's 100, because 10 times 10 is 100, and so on. Some examples of scientific notation would be something like 3 times 10 to the 4th. Negative 8.1 times 10 to the 10th. Okay? These are examples of scientific notation. The number in front is between 1 and 10. They can be negative. It's just the value has to be between 1 and 10. And then the exponent obviously tells us how to move the decimal. So we want to be able to switch from standard form to scientific notation, and from scientific notation to standard form, and things that are kind of in between all the way to scientific form. So here we have 420,000. So we want this to be in scientific notation. So the easiest way to figure this out is to put a decimal where we would have a number between 1 and 10. So this would be 4.2. So our A is going to be 4.2. Then times 10, what we have to figure out is the B value. So we want to know how far did our decimal move. 1, 2, 3, 4, 5 spots. So our B is 5. Okay? This was a big number that got smaller, so that's a positive 5. If it was a small number that got bigger, then it would be negative, because those have to work in opposites. So this one is in scientific notation. We need to change it into standard form. So what we do is we just move this decimal place this many spots opposite. So we're going to go 1, 2, 3, and what we have to do is put any zeros in any place that we have open little arcs. So this would be 2, 7, 5, 0. So we have 2,750. This one isn't in scientific notation, but it's close, so we want to finish it off. So to turn it into scientific notation, we have to take this and move it one more spot. So we really need 3.25 times 10. Well, it had already been moved 11 spots, so I moved it one more, making it 12 instead of 11. Okay, this one is negative, so to make it between 1 and 10, we put a decimal there. So we're going to get negative 3.045 times 10, and then we need to know how far we moved it. 1, 2, 3, 4, 5, 6, 7 spots. So that's a 7. Here we want to turn it into a standard form. So we want to move our decimal 6 spots to the right because that's a positive 6. So we're going to move it once, and then we got to move it 5 more times. 1, 2, 3, 4, 5. So I'm going to need 5 zeros based off of that. Negative 1, 4, 1, 2, 3, 4, 5. So this looks like 1,400,000. Alright, now let's do some math with scientific notation. First thing that we want to do is add and subtract scientific notation. Well, the first important thing about adding and subtracting scientific notation is the exponent. If these exponents aren't the same, you can't add or subtract them. So what we do is we either have to make one of them, or we basically just have to shift the problem so that they are the same. Since these are both 4s, we can add these exactly the way they are. So we just go 6.5 plus 2.7, which is going to be 9.2, and then we keep our base 10 the same, so times 10 to the 4th. And then if this was not in scientific notation, we just adjust it to keep it that way. This one, the bases are different. So we have an 8 here and a 7 here. So we either need them both to be 8 or both to be 7. So I'm going to turn them into both 8. So this one's going to stay the way it is. This one, to make it 8, we have to move our decimal 1 spot to the left. This is going to be 0.74 times 10 to the 8th. So now what we can do is we can actually do this subtraction, 8.6 minus 0.74. So that's going to give us so it looks like 7.86. And again, we would keep our base 8 right there. Okay, last thing, and a little bit simpler, is actually the multiplication. Typically what you'll see is you'll see them put in parentheses just so you can kind of see which ones are which. Well, what we've got is 6 times 10 to the 4th power and 3 times 10 to the 5th power. Well, we can actually use our exponent knowledge here. We can take the 6 and the 3 and multiply them. They're going to give us 18. Then we can take our bases, 10 to the 4th and 10 to the 5th, and add their exponents. So this is going to be times 10, and 4 and 5 make 9. So this is 18 times 10 to the 9th power. Well, this technically isn't scientific notation. Decimal point is here. We want this between 1 and 10. So move it over. We're going to get 1.8 times 10. And since we moved it to the left, we got to make this number bigger, to the 10th power. Alright, this lesson was on scientific notation. If there's any part of it you didn't understand or you need to watch again, please pause the video, rewind, rewatch, and bring any questions to class. Thank you.